Hey guys, today we are learning about partial variation. Whoops, I've already messed up. All right, there we go. Partial variation. So what is partial variation? This is a linear relationship where one variable is a constant multiple of the other variable. However, unlike direct variation, we then add a constant. So let me zoom in so my writing is somewhat legible. So a linear relationship, that's the official scroll sound, where one variable is a constant multiple of the other, plus a constant. Remember, a constant is just a number that's not being multiplied by a variable. So, for instance, let's see. The cost of a field trip, which we'll call C, is $5 multiplied by the number of students plus $20 for transportation. So, if we were to write out our equation here, we've got, whoops. Oh, turns out I don't know what I'm doing. All right. C is equal to, and we take the $5 and we multiply by the number of students, which we called X, so 5X. But then we have to add this 20, okay? And this right here, this plus 20 is what makes this partial variation. If it was direct variation, it could still have this part, but it wouldn't have that plus 20, okay? That plus 20 makes it partial variation. So let's see. So we're going to draw a table of values and illustrate the relationship graphically, which just means fill in the table of values and graph it. So we will do, let's just go 0, 1, 2, 3, 4. All right, so the big difference here is that if I bring no students, which obviously I wouldn't do, but that's besides the point. If you bring no students, if it was direct variation, it would just cost nothing. But with a partial variation, there's still a fee. So it will cost $20 no matter what. It doesn't matter how many students we bring, we have to pay that $20. Okay? Then obviously if I bring one student, it costs $5 more, $5 more, $5 more, and $5 more. All right, so if we were to graph this, whoops, okay, there we go. So I'm going to start at 0. I'm going to go up 1, 2, 3, 4, 5, 6. And we'll call this the number of students. And you know that the number of students is going to be the independent variable and therefore go on the bottom, because the cost of a field trip doesn't tell you how many students you brought. I mean, you can learn that information, but the cost doesn't determine the number of students. It's the number of students that determines the cost. Okay, so we'll have cost over here, and that'll be measured in, whoops, oh my goodness, measured in dollars. Yeah, and I'm just going to go up by tens every other block, so I guess I'm technically going up by fives, but 30, 40, 50, 60. That looks good. Okay. Well, I guess we should give it a title. We'll call it field trip. Field. I should spell field trip right. I before E, guys. I before E. Field. That looks wrong. But it isn't, probably. It's probably right. It is right. Okay. So, I'm just going to use blue here. And we'll say, so if there was, we said if there were 0 students, it cost $20. Okay. And then we went up by 5 every time we added a student. Okay. Simple enough. So we had those points. And then I can draw a line through it. Although, once again, I always have troubles with this because, oh, yep. Who knows what's happening right now. Let's see, how can we do it? Nope. Oh, that wasn't even close. Something like that. Did I get them all? I'm off by a little. Whatever. You'll be able to do a better job than me. Okay? I want to keep pushing the check mark, which is going to mess up my next part, but whatever. All right, so if there are 20 students, what is the total cost of the field trip? So, before we get to 20, what did it ask? Was I supposed to do... Normally I edit this part out, but I've been having troubles with the editing. So anyway, this part where I don't know what I'm doing. All right, I think that's good. I think we answered that. What does the graph look like? Oh, well, we didn't answer it. So we said it's a line. So it's a line and does not go through the origin. Okay, and again, that's what separates this from direct variation. Direct variation has to go through that point right there. We did not go through that point right there, which is what makes it partial variation. The fact that we started up at 20. Okay, so if there are 20 students, what is the total cost of the field trip? It says to use your table, graph, and equation. I'm not going to use the table or the graph because I didn't make them big enough. So anyway, we'll just use the equation. So we'll say C equals 5x plus 20. Remember, you have to write down your equation every single time. Those are your communication marks. Okay? So we're going to let x be the 20. You know what I'm going to do? I'm just going to, because I want to actually show you what we're doing here, I'm going to cheat. I'm going to take this. You're not allowed doing this on a test. You're not allowed changing the question on a test. But I'm going to change the question so that I can actually do this. I'm going to do it with the equation, and then we're going to show it with the graph and the table values. So I'm just going to say 5 times 6 plus 20. So 5 times 6 is 30 plus 20, and we get $50. So it'll cost $50. Okay? So if I were to try and figure that out with the table, then I would just extend it here. So I only went to 4. Well, I would go to 5. That's a 6. I'm just getting ahead of myself. 5 and a 6, in which case I would just go up by 5, and then I go up by 5, and I get 50, which is the same as the answer I got here. So that's good news. And then if we look at our graph, we would go up here. Now I'm going to actually show you the correct answer because my line of best fit did not exactly line up, but it's supposed to go through that point right there. I'll make my dot really big. Okay. And then you can see that would take us to 50, which is the answer. Okay. So we got 50 no matter how we did it. All right. So our conclusions. On a graph, if two variables are vary partially, the graph will not pass through the origin, which is 0, 0. Okay. As an equation, if two variables vary directly, it will follow the pattern y equals mx plus b. And the m and the b are the letters we usually use in this. You'll see lots of that over the next couple of units. But both the m and the b will be a number. So, e.g., so I would have like y equals 2x plus 3. Okay, it'll look something like that. The 2 might be, or 2 will be a different number, or it could be a different number. The 3 will be a different number, or it could be a different number. But it'll still have that basic form. And that's it. So until next time, go Sabres.